Okay, welcome to our YouTube channel, Land Civil Engineering. Just to give a brief introduction of myself, I'm called May Armstrong. I have a technician diploma in land and survey here in Cameroon, and a bachelor degree in cartography here also in Cameroon, and a master in technology in GIS and remote sensing in the Africa Regional Center for Space Science and Technology in the under the affiliated to the United Nations under the umbrella of FUTA, that is the Federal University of Science and Technology Accurate, which is based in Nigeria. Welcome to our YouTube channel. Here in this our YouTube channel, we'll be training you on the application of land surveys in civil engineering project. We'll be training you from A to Z. I've been working on several projects for the past 15 years, several civil engineering projects for the past 15 years as a geospatial specialist. So I'm going to give you everything in the best of my knowledge so that you'll be well equipped. Believe me, I've been working on road projects. I've been working on projects related to waterworks. I've been working on projects related to implantation or setting out of engineering structures. So we are going to see how we can apply land survey technique in civil engineering related to this project. Actually, our training is subdivided into two parts. We have the theory and we have the practical. Now, I'm going to give a brief rundown of the theory. Under the theory, we have planimetry. We have chapter one. We're going to talk about planimetry. When we hear about planimetry, we think of on a plane, isn't it plane, like a two-dimensional view of an object or of a structure. So we are going to deal with planimetry, and under planimetry we are going to talk about the notion of coordinate system. We know that nowadays our modernized way of implanting or setting out structures, we use coordinate system now to set out engineering structures. It can be road, it can be building. So what are coordinate? So in a brief way, in a layman, or not in a layman way, but in a well simplified way, we can define coordinate as these numerical numbers that defines the relative position of points on the Earth's surface, isn't it? I don't want to go deep into the terminology to define coordinate. We are going to get into that. Let me give another example. If we assume that this is a structure or this is a board, of course, this structure is made up of 4 points. We have point 1, we can give a matrix of this point. Point 1, we have point 2, we have point 3, we have point 4. Point 1 is defined by its coordinate x1, y1. Point 2 is defined by its coordinate x2, y2. Point 3 is defined by its coordinate x3, y3, and point 4 is defined by its coordinate x4, y4. So each point, be the structure or any structure you can think of, is defined by its coordinate. So when we are done with coordinate system, we are going to discuss, or we are going to talk on how can we use now this coordinate system to set out engineering structures. From coordinate system, now we are going to move down to chapter 2. Chapter 2, we are going to talk on boundary surveys. Boundary surveys, when somebody comes to you and as an engineer, civil engineers or urbanist or surveyor, somebody comes to you and he wants you to draft a plan, or to come up with an architectural drawing of a plan. The first thing that comes into your mind is, what is the geometry of the area what is the geometry of the area you want to realize that project? That's the first thing that comes into your mind. The moment you do not know the geometry of that area, you do not know the surface area, you cannot just dive into start drafting, you understand? So you have to be very careful. So many engineering projects, big engineering projects, we need precision. So we are going to see how we can use land survey technique to precisely come out with a design, the geometry of a project area. Yes, we're going to come out with the length, the width, the surface area. Okay. When we are done with that, when we are done with boundary surveys, We are going to enter now into road surveys. Yeah, road surveys. And just before I forget, remember that land and survey is just a subset of civil engineering. Civil engineering is very vast. So when you are so it's very vast with different branches, from structural engineer, water engineer, and so on and so forth. So land and survey is just a subset of civil engineering. So we are going to deal with road surveys. Road surveys, we are going to see how we can, discuss on the different parts of the road, and how we can calculate the different elements of the road, how we can set up the different part, the curves, be it the horizontal curves, be it alignment or the vertical curves. We are going to deal with that A to Z. That will be chapter 3. Then on chapter 4, we are going to deal with the water engineering. Water engineering, hydrology or hydrography. Of course, any project related to hydrology, hydrography. When you are let's say when you are dealing with an engineering project to construct a road, of course, you want to do some sort of hydrographic surveys to see how water flows, to do some sort of water flow analysis, so that we might not, at the end of the day, we might have a good drainage system on our project area. Or still the same, if you have been given a project, let's say you have an engineer, you have been given a project to construct a hospital. A hospital, you will want to do some sort of the surface analysis in the way that when water falls, or you want to design a good drainage system in the hospital so that there will not be stagnant water in the hospital. So you have a civil engineer, you are obliged to know all this, of course. Then we are going to deal with dams. We are going to deal with a lot of things as far as water engineering is concerned. So that's just a brief summary. So there we are done with the part with the planimetry surveys. Now we are going to enter into altimetry surveys. Don't forget, I said, and our theoretical part of our course is divided into planimetry and altimetry. So I've just given four chapters on the planimetry. We said notion of planimetry, notion of coordinate system, chapter 1, then chapter 2, boundary surveys, chapter 3, road surveys, chapter 4, water engineering or hydrology or hydrography engineering. So we're going to do that. Then now, on the second part of our training now, we are going to deal with the altimetry. When we talk about altimetry, we think now of altimetry as a height. Name just goes altimetry, height, altitude. Yes. So in engineering, as a civil engineer, as an urbanist, as a surveyor, you must master the notion of altimetry, and you must know where and when to use it. You know that when we want to calculate, for example, if you're working on a road project, every time when there's a road project, there's a lot of cut and fill. And you as a surveyor, or you as a civil engineer, you as an urbanist, you are the one to go to the field to collect your altimetry data. X, Y, and Z. Each point is defined by its coordinate X, Y, and Z. That is altimetry. Now you're the one to go to this field to come up with all this, to pick up this data. And now at the end of the day, we can use this data to calculate the volume of earthwork, which is very important in engineering project. Okay, so under altimetry, we are going to deal with leveling. So leveling surveys, chapter 1, we are going to deal with leveling surveys. Leveling surveys now is this technique that is going to permit us to collect geospatial data, that is surveys data that will help us to calculate altitude of point, or the height difference between point, and we are going to use the altitude or the reduced level. Those are those synonyms: altitude, reduced level, elevation, to calculate on the volume of earthwork. Okay, that will be chapter 1. Then now we are going to go now to chapter 2. Chapter 2 will be 3D terrain modeling. 3D terrain modeling. Now, of course, when you want to realize a project in a giant project in a vast area, you do your altimetry surveys to come up with a three-dimensional perspective of this terrain, and we can use that. We can study this terrain to see how engineers can study this terrain to see how they can better adapt the terrain to fit into their project. So that will be chapter 2, 3D terrain modeling, 3D terrain modeling. Now, under chapter 3 now we are going to deal with road profiles. Yeah, of course. Remember that on planimetry we talk about road alignment, vertical curves, horizontal curves, alignment of road. But here now we'll be dealing with road profiles. So now road profiles are like the cross-sectional. We have a longitudinal section. It's like the section from A. Let's say if you have a road from, let's say, from Akure to Ife. So within the central axis of that road from Accurate to Ife, that is the longitudinal section, the longitudinal section. So we're going to see how to come. We're going to study how to come up with a longitudinal section. Of course, we use the longitudinal section we use the longitudinal section to study the gradient of an area that have been allocated for a road project. We study the gradient and we can now adapt the gradient to a suitable gradient that cars can take. So we're going to deal with a longitudinal section of a road from, let's say, from Akure to Ife. Of course, remember that road also we have the lateral, we have what they call from east-west. So we can decide on a road project normally what they usually do. They usually take section of road east-west, let's say within an interval of 20 meters. So let's say you are leaving Akure, or let's say you are leaving Port Harcourt to a nearby city. So east-west, every after 20 meters, we want to be cutting the road to see how the road behaves. You understand? So all these elements, we use them to come up with to do what they call estimation of volume of earthworks. And so yeah, so we'll get into the data. We are going to get into the details of that. So now, that is just a rundown, the summary of our training. When we are done with the theory, now we are going to get into the practical. Before we talk about the practical, there's only one, and there's a way. There's a way you're going to support us. You're going to support us by subscribing. By you subscribe, you hit the notification button. That way, we'll be motivated. When we see us, when we will be motivated to drop more videos. So please just subscribe, hit the notification button, so that we can, you can fuel us to continue with the subject. Okay, practical now. On a practical, we are going to deal with two powerful software. If you are a civil engineer, if you are a surveyor, if you are an urbanist, you are obliged to know this software. You must have heard of it. We have Autodesk Civil 3D. Autodesk Civil 3D. As a civil engineer, you are obliged to know the software Autodesk Civil 3D. Under Autodesk Civil 3D, and one thing that I want you to know is we are going to give you the setup. Yeah, we are going to give you the setup. Then we are going to guide you on how to install the setup. Thank you. Okay, under Autodesk Civil 3D, we are going to deal with road design. We are going to see road design, a project from road design, that is road alignment, road cross sections, volume of earthwork from A to Z. By the time we are done with this, you will know everything related to road project. When we are done with that, we are going to do with pipe network system. Pipe network system, that means when we deal with that, when we are done with that, we'll be able to work on water company, gas and oil company, and yeah. Then now, after that, we are going to move site design. Site design, that is grading, earthworks design in a three-dimensional perspective, three-dimensional view. We take like contours, grading, all the sort of things. We're going to see details. I don't want to get into that. Then number four, we are going to go into collaboration and sharing. Beam integration, we are going to see how we can integrate and civil 3D data into Beam. Okay, but we're not going to go deep into Beam, but we're going to see how we can integrate it. Then you can move forward into that. And now we are going to deal with another powerful software. That one is used for water engineering, which is known as HECRAS. HECRAS. So HECRAS is actually hydraulic engineering centers river analysis system. Hydraulic engineering centers river analysis system. It's actually a software built by the US engineers. It's widely used in engineering as far as water engineering is concerned. So there we are going to talk about floodplain analysis. We are going to deal with rivers and stream modeling. We are going to deal with bridge and culvert design. We are going to deal with dam break analysis. We are going to deal with stormwater management, and also we are going to deal with coastal engineering. Okay, that is a rundown of the summary of what we are going to train on. By the time we are done with our training, you'll be well equipped, and your support. Don't forget to subscribe and you hit the notification button. Thank you very much. Until then.